All right, in this part of the lecture, we're going to demonstrate working with files, and that'll round out our week 11, chapter 12 demonstration, and should give you enough of the building blocks between this video and the previous one about exceptions to be able to do the assignment for this week. So for this demonstration of a file, we're going to write a short program that creates a list of double values in your homework this week. You're doing integer values, just to highlight that difference. But for this demo, we're going to do double values. We're going to write them to a file, and then we're going to read them back in from a file. And that should give you enough to be able to complete the assignment. So a couple of things, I'll just talk through them as we go. As I said in the discussion board post or the announcement this week, the reason why it's hard to have a chapter on how to read and write files or do any input and output from the network or anything else is because there are so many different ways to do it, and they're all good. And so we just don't know, we don't want to overwhelm you with all the ways to do it. So I'm going to show you the most simple way to do it. It's geared towards the assignment for this week and also geared towards your final project. This will probably be the easiest way to work with your final project's requirement to read and write your data to and from files. So here we go. We've got a main program, and we're going to come back to main in a minute. I'm going to define a couple of method signatures here. Our first one will be to write the file. So we're going to do a public, we're just doing quick methods, public static, void, write, and we need to give it a file name to write our data to. So we're going to say string file name, and then we're going to pass the data that we want written. So we're going to say it's a double array of data. All right, so the next thing we're going to do is we're going to have a method that returns an array of doubles, and that's going to be read data. So just public static, we're going to return a double array read data, and we need to give it the file name for us to read, and then it's going to do its thing. And for now, right now, we're going to return null. We'll come back and fix that in just a second once we get the data written out. I've often found that when you're reading and writing to and from a file, if you have your own custom file format, which is what we're demonstrating here, then it's easier to do your writing code first so you know what the format is that you've written, and then you can read it back in. If you have a well-defined format that's documented somewhere, then it doesn't matter which one you do first. And in our day and age, just as a professional tip here, the file formats that we use are generally standardized now on either XML or JSON data, and they're structured well enough that they can pretty much hold any data we want to give to them. And why we would do a custom format would have to have very specific reasons. It might be binary data, for example, and then we would have all binary data has to have some kind of a custom format to it. But we're just going to demonstrate the easy stuff with text formats, and we're going to do a custom because parsing JSON is a little bit more involved, and either we'd have to write our own parser, which can be pretty complex, or we'd have to use a library, and our class is not set up. We haven't taught you how to pull in external libraries for your Java programs yet. You'll learn that in the next course. So we're just going to write our own custom format, and our format for our file is just going to be one double number per line in the file. So let's do that. Let's walk through this method. So the first thing we want to do is we want to create a output stream or an output writer. And in Java, there's a difference between things that are called streams and things that are called writers. Streams came first, and they worked with byte data, which meant that they could work on ASCII, the ASCII character set. And but a funny thing happened in the 90s. We became aware in the United States that there were millions of people who didn't live in the United States, and they spoke different languages. And not every letter of their alphabets or their communication system could be represented in the 255 characters that we have in the ASCII character set, or the extended ASCII character set. So Unicode became very important, and all that Unicode does is, instead of representing characters using 1 byte, which means we could have a maximum of 256 different characters, to using 2 bytes of data, or even more than that. But a 16-bit number, 16-bit character is what Java supports. And with that, you can actually support 65,000 different individual characters. And so the streams operate on byte-oriented data, and the writers operate on character-oriented data. So we're going to do it. We're going to create a print writer, because a print writer has a really nice method called printline. We've been using it all semester long. It's the same as a print writer and print stream have very similar methods. So they both have printline methods, and they have a printf or a format method too. We're not going to use that necessarily in this example, but our system.out.println calls that we've been doing all semester, that's because system.out is actually an object of the print stream type, which is byte oriented. But we're going to demonstrate a writer here. So we're going to say print writer, and we're going to call our variable name file for lack of being more creative. IntelliJ wants me to import print writer because that's in the Java IO package, so we'll do that. Equals new print writer, and we have to give it the file name. So we'll just pass it the file name that we got passed. And now print writer has an error, and we're going to take a look and see that print writer throws a file not found exception. So we either have to handle that or propagate it back up. In our case, we're just going to propagate it back up. So throws file not found exception. And of course, that's another class and another package that needs to be imported. So we'll import it. For those following along, I'm on a Mac, and I hit the Option key and the Enter key while on that error, and it popped up the things that it could do to help me. And one of those things, let's just demonstrate that really quickly. Let's go delete this line. So this is an error again. So I'll put my mouse here. I hit Option Enter. I don't know what the keystroke is on Windows. It's probably Alt Enter. And then it pops up. And there's lots of things it offers me to do. Create a class, create an inner class, create a type parameter, or import the class. And that import the class is what I want here. If you don't know what code help does, don't choose it, because it'll just make matters worse probably. So all we've done here is we've said that our write data throws a file not found exception. So that means our main is going to have to handle it, which we're okay with that, because write data at this point, we don't know what write data, how it's being called or where it's being called. And so the fact that we can't write the data, probably we don't want to handle the exception here and give the caller reason to believe that the write data worked, right? Because we don't return anything. So if this method returns successfully, we can only assume that it worked. So the way we make sure that it doesn't return successfully if there's a problem is we throw that error, we throw that exception there. All right. So now we have created our file, and we're going to then just simply walk through our file and print walk through our list of doubles and print them to our file. So we're going to say, we'll do a for each loop. So we're going to say for double D in data. Then we're just going to do a file.println D. And then at the end, we have to make sure we close our file, because if we don't close our file, then it's going to hang open and we may not actually get all of our data written to it. Another thing that's helpful to do especially when you're printing output to a file, is you probably want to call the flush method. So for performance reasons, the operating system might not actually send all the data to your hard drive when you call println or when it calls write underneath the hood. And it might be sitting in a buffer somewhere. So we want to make sure we flush the file and then we close it, so that everything that was written to the file actually makes it to the hard drive. So that's pretty cool. Hopefully you're seeing something that could go wrong here. What if for some reason the flush can't work, or for some odd reason the println doesn't work? We might get some kind of another exception. And even though they don't declare that they throw exceptions, if they did, we'd be getting errors here because we're not handling anything but the file not found exception. So this is where we can make very good use of our try with resources. So we're going to create our file as the resource of a try block. And in that case, because we're doing a try with resources, we don't have to do the file.close, because anything declared as a resource in the try will be closed automatically in an implied finally block right here. So we're good. So that's pretty cool, right? Let's see if this works. Let's write something in our main really quick. Let's do this. We're going to create a double array, and I want to demonstrate something that'll help you with the homework. So we're going to actually do an array list of doubles. So I'm going to say array list of double. I have to use the capital D for double because array list can only hold objects. We'll import array list, and the capital D double is the object wrapper around a primitive double. So we're going to call this double data equals new array list, and it knows the type from the left side. And then I'm just going to say double data dot add, and I'm going to add in a double like 0.0. And let's just add a few of these. We'll add 5. 1.0, 2.5, 3.7, and 1e. So let's do 1.26 e to the minus 23rd. That's a pretty good double. I don't know if I got that right, but is that the mole? What's 1 mole in chemistry? I don't remember. Don't write comments on the YouTube video for this, but I was never a chemistry major. Anyway, that's an interesting number, and it happens to be a double value. So everything's happy. So then if I say write data, and I'm going to give it a file name, we're going to say doubles.txt, and then we'll pass our double data, except double data is an array list and we want it to be a double array. So let's convert it to a double array. And the way we do this is we can say double array. We'll name it double array for the lack of creativity there. And there's actually, array list has a method that will turn it into an array. So we say double data dot to array. And I think we might have to make this a capital D double too, but we're going to try it this way. We're going to say new double array, and we're going to make that empty. And let's see what the error message is here. If we make it a double array, does that work? Yep, I think that's what makes it happy. We're going to do capital D double, and that makes the line of code happy. And then we can pass in our double array. What's wrong here? Oh, double array. Let's just fix this right now and just do capital D double. The problem is when you store stuff in array lists, it has to be an object. So we created the capital doubles as object wrappers around primitive doubles. And now we notice that write data gets an error. It says unhandled exception, java.io.file not found exception. So if I look down here at the quick tips, it says add exception to method signature. If I click that, I'm going to get points taken off on my assignment. Your main method should not throw anything. Your main method should handle any error that it's supposed to handle. So in this case, what do we do? Let's do this. Let's wrap this in a try. Try catch, file not found exception. How do we know that file not found exception is what we have to catch? Because the method we're calling throws it. So we know by name what it is. And then we can simply say system.error. We've decided that the appropriate action for this exception is just to tell the user. Couldn't find the file to write. So you might be asking yourself, well, what if the file doesn't exist? Does the file have to exist before I write to it? No, print writer will actually create the file if it doesn't already exist. If the file does already exist, it will overwrite the file and wipe out whatever happened to be in it. So you want to be careful that way, and you might want to do a check first. In this example, we're not going to check. We're just going to slap that data right over the top of whatever might have been there. But if for some reason print writer could not create that file for us, maybe you had a full path to it and something was wrong in the path where a directory didn't exist, then that is that's where you're going to get a file not found exception, unable to create the file. Maybe it's not the best description of what happened, but that's what they chose to do. Okay, so this program is ready to write, or ready to run. We already wrote it. So why don't we do this? We're just going to start right here and walk through, and we're going to watch. We're going to watch the saga unfold. How's that? Oh, wrong example. I needed to create, that's from the last video. Let's actually make sure we create a run demo. See, this happens to us all the time. It's not just you. All right, here we go. So we create our array list here, our double data. You can see it has size 0, and now size 1, 2, 3, 4, 5, and we can actually come down here in the debugger and look at this. We see all of our values. That's pretty nifty. And now we're actually going to convert this to an array of doubles. So now we have a double array, and it's got all the exact same values in it. You can see it's a different object than the array list. And now we're going to call write data. So we're going to step in, and we're going to create our new file, kablamo. And now we're going to go into our file, and we're going to go into our list, I guess, and print out each thing on its own line in the file. So we're just going to step over. We should do this 5 times. We know we get to the end when we see that exponential notation number. Kablam, and then we're going to do a file flush, and then we're done. No exceptions, and our file now exists, and our program ends. So very cool. So where did it go? It went to right here in our project file, because we told it to put it here. If you wanted to put it in a absolute file, you could say C:\\. If you use backslashes, you have to double slash them. Temp, whatever you wanted to do, you could put it there, but if the temp directory doesn't exist, that's where you'll get a file not found exception. If you happen to be on Mac, then you don't have a C drive, but you could say /temp if you wanted to do it that way too. But in our case, since we don't use a path, it's going to create it in the current directory where the program is running. And that's what your assignment needs to do, because I won't let you write files to anywhere, any random place on my hard drive. So you can only write, your assignment can only write to the current directory where the program is running. But anyway, if we open our doubles.txt, we'll see here, we've written our data out to the file. So, hey, it works, cool. And that file didn't exist before our program wrote, or before our program ran. But if I come in here and I add, and let's say I change, we just add 1 to everything. So 2, 3, 4. We add 1 to everything, and we run our program again. Our doubles.txt is going to be overwritten. So it happily ran, and now instead of starting at 0, we got 1, 2, 3, 4, and the 2 to the very small number. So very cool. So we know that it all works. Now let's undo that silliness there. All right, and now we're ready to read the file in, and we want to return an array of doubles. But for consistency, I'm going to make that a capital double. A double array, and we give it the file name. And so we've been using the scanner all semester to read structured data in from the input. I recommend for this week's assignment and for your final project that you also plan to use the scanner class to read your data in. It's just easier that way. So we're going to create a scanner, and we'll just do our usual. Actually, let's do this. First thing we want to do is create something to hold the data. We don't know how many lines of data have been read in, and so that's not cool for us, right? Because I don't know how big to make this array. Luckily, we have the array list, which we're going to use here too. So we're going to say array list of double. Now we're going to say data equals new array list. And now, just as a reminder of the array list is what's known as a generic type. So we need to tell it what type of data we're going to hold in this one. So I can have an array list that manages doubles. I can have an array list that manages strings. I can have an array list that manages any object of anything that I have in my program, custom objects that I've written or standard objects that Java provides. On the other side, we all got tired of typing everything over and over and over. You know how I feel about repetitive code. And so finally, somewhere in a recent version of Java, I think it was Java 7, they gave us the ability to tell the compiler, hey, I told you over here on the left side, go back there and figure out what I meant. And it just knows that we're dealing with doubles here. So I don't have to type double one more time on the line of code. All right, so I've got my holder for it. So now we're going to do a try, and we're going to say scanner, and we're going to import our scanner input. Let's call it file just for consistency, equals new scanner, and we give it our file name that was passed into us. And that means when we're done with the try, because we have a resource associated with the try, the resource will be closed. So that's very clean. Our scanner doesn't live on after this method closes. So now we're just going to simply call. We're going to say, how do we want to do this? We're going to say double. Well, we could either do double because Java autoboxes it's called autoboxing, where it automatically wraps a primitive double in an object double. We'll demonstrate that here. So double D equals file.next double. So that's pretty cool. And then we can simply add that to our list. So we'd say data.add D. Now we don't get an error here, even though we're using a primitive double here and our array list is made of object doubles, because Java will automatically say, I know what to do with a primitive double when you need it to be an object double, and it'll automatically wrap it in an object double for us. So that gets handled automatically. And then the try is done, so I'm going to convert my data to a array using the same technique that we used up in main. So we're going to just say return data.toArray new double array, and we're done. Now, what's actually happening here, this toArray call, it's not my favorite method. I don't really like how they did it, but what they've done is you pass in an array that you want to have the data put into it, and they will try to stuff as much into this array for whatever size, and if they can't fit everything from the array list into the array, then they'll actually create a new array, copy everything into it, and return it. So the way I call this is I always give it an empty array just to set the type, and it'll immediately see that it can't stuff everything in there. So it'll, inside of the toArray method, it'll actually call the code to create a new double array, and it'll start putting everything into that instead, and it will return it. So right up here, the array I passed in had no capacity to hold any doubles. It just met the requirement of being the right type. So it created a new one and it returned it, and we stored its value here, or stored its reference in the double array variable. So we're doing the same here. We're just not store it, the returned array reference, we're actually returning it as our double array here. So that's pretty cool there too. Now, I'm thinking of the best way. We're going to run this, so let's figure this out here. So we've written our data and we've closed our file here, so we're going to reopen our file when we call our read data. So we're going to say double array new data equals read data, and we're going to give it the same file name. Oops. Doubles.txt, which is cool, but why do I have to type that twice? That's not really good programming. So let's declare a constant up here and say static private string static final private string file name equals doubles.txt. What this does is it makes it very easy for me to make sure I have the same file name every place I need it. And that way I don't have to worry about typos, because as you've seen, I am full of typos when I code. All right. Now, why don't we have to wrap this in an exception handler? The reason is the scanner doesn't declare any exceptions. Now, we know from prior experience that if we try to read a double that can't be converted to a double, then it's going to cause an input mismatch exception, in which case somebody needs to handle that. But in our case, we're going to come back in just a second and handle it. And it's going to be best to handle that in the scanner itself because, well, it depends. Does our main program want to know if not all of the file could be read, or does it want to just get whatever is a double out of the file? So we'll take a look at that. So we're going to call read data, and I think we're ready to go. So let's start our debugger. Well, before we do that, let's actually do something visual with our data. So we'll just do a for, and we'll say double D in new data, system.out.println. Look at that. It works just like our file writing does. And we're just going to put D. We're going to print that baby out. So here we go. We're going to build our array. Step, 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 step. Now we're going to write the array. Boom. And if we come over here and look at doubles, there's the original data. So now if we come back in here, and just to prove that we're doing it right, while the file is closed, I'm going to edit it. And I'm actually going to add a new line. I'm going to say 123.4. And IntelliJ saves it for me automatically because that's my setting. And then we're just going to step. Oh, I went to go into it. What's happening? It looks like I got a problem. I got an input mismatch exception on read data line 49. Well, it wasn't a double. So what happened here? In this case, let's take a look and see what did happen. I'm not sure what happened. Here we go. What's going on here? Let's figure this out. Step, 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 and let's dive in here. Now, one thing I didn't do is I didn't put that in a loop, so that could be a problem. We're only going to read the first line. But let's take a look. So we create our scanner and we say, what is our file name? Should be doubles.txt. And I have a 0.0. So if I say file.nextDouble, why isn't it reading the file.nextDouble? Interesting. I'm looking for a double, and it's not giving me a double. So let's take a look and figure out what's going on here. Let's do a little bit of our debugging technique here. So instead of reading the line in, or the next double, let's read the line in and see what we get. So we're going to say string line equals file.next line. And let's see what this looks like. So we're just going to stick a breakpoint in here so we don't actually miss it. And then we're going to debug. And we'll go all the way down to our method. And here we go. So create the scanner. I'm going to read the line in. and we say file. So we're not actually getting anything in. There's not a line. Let's try that again. Even though we don't normally do print lines and utility methods, we're just debugging. So we're going to print the line. So I'm walking through this. I'm honestly not sure what's going on, and this is how programming works every day, even for those that have been doing it for years. And I'm hoping that you're going to glean something from my debugging techniques here, trying to figure out what's going on. So we'll continue on until we hit that breakpoint. Step, step, step. So what is our line? Our line is the string double.text. Oh, why does this get me every semester? Because it only ever comes up every 4 months. Do we see what happened here? I said create a new scanner using this file name. And scanner doesn't work that way. If I pass scanner a string, it says, oh, I'll create a scanner out of that. I'll create a scanner on that string. So it's going to give me, it's thinking that I should have given it a list of doubles as a string here instead of telling it to open a file name. So what I actually need to do, and I can figure this out by going and looking at the Java docs for scanner, I'll see the constructors, and the constructor that takes in a string says, create a scanner for the string. If I want to create a scanner for an input stream, I need to create an input stream first. That's what system.in is. Oh, why does that always get me? Every single semester. So luckily, now we know what's going on, and we now have a chance to correct the fact that we don't even have a loop going in here to read the whole file. But we create a string file name, and now we need to actually create a new file. So we're going to say new file reader, and the file reader class knows to take a file name and handle it the right way. So file reader says, I don't know what to do if the file's not found, so we don't know what to do here either. So we're going to say throws file not found exception. So here we are now with our file not found exception on our read data. That's going to cause us to have to change our main just a little bit, and that's okay. And now we're ready to go. So if we can find the file and open it, then we're good to go. And now I just have to say, while our file.has next, while there's anything left to read in the file, then read it and try to convert it to a double. So that's cool. And our doubles.text, we've changed the content so much. So we'll come back in and do the little demonstration, but that should take care of everything. So, oh, I can't compile yet because read data also needs to be wrapped in a try-catch. So we're going to add another try-catch. You might be wondering, well, if I already have a try-catch on file not found, why not just put it up here like this? And the reason is, I'm going to handle the error differently depending on whether I'm writing the data or reading the data. And so I don't want to necessarily put them both in the same try-catch blocks. So we're going to catch file not found exception. We're going to say system.error.println couldn't find the file to read. And that's the difference between our two error handlers. One is reading and one is writing. So we'll notice if we don't get if read data throws the exception, we won't actually print anything out. All right, so now we should be ready to run our program. And we will continue on down to inside of our read data method, and let's see how this goes. So now we've got our file open. And we're just going to keep going. And we're going to keep reading doubles. You can see our double D keeps getting values in it. We'll just keep going until we get to our cool number that tells us we're at the end of our file. Just happened to work out that way. It didn't have anything after that, and therefore we're done, and we're going to convert to an array, and our new data now has our array. So you can see our double array has those numbers in it. Our new data has those numbers in it. They're the same because that's what we expected. And now we're just going to run our code. We're going to run to completion, do our for each loop, and print everything out, which we can see in the console. Huzzah! So let's run this again, but we're going to pause briefly before we actually open the file for reading, and I'm going to tweak the content of the file. So here we are. We're about to open the file, and I'm going to add something new here. We're going to say minus 123.1234.5. How's that? So now we've got an extra field of data, and this is just proof that our reading code is actually reading the file and not just regurgitating the original array that we wrote out. And that's something that you want to do in your program, because a lot of students will they'll read the values from the user for your assignment, and then they'll write them to a file, and then they'll read them from the file, but then they'll use the original array that they got from the user to calculate the average. And that's not going to be right. You have to calculate the average on the numbers that you read in from the file. There's no way that I'll know except by reading your code to see whether you got that right. But I do read your code. So, all right, so now we're ready to step over this, and we're just going to see, I'm going to step out. We're going to run into, actually, I won't step out. I'll just run down to this line. So where is it? Run to cursor. There we go. And we'll see here that our data did it not get saved? What happened? Let's try this again. So if I debug, see, this happens to even the best of us, and I'm not even the best. So we're going to run to a breakpoint here, and now we're going to say minus 1234.5 and save our file. And I think that should get it to where it comes back into us, right? I mean, we're proving to ourselves that we're actually reading our data. I just wanted to make sure that if I change the file contents before I open it for reading, that my file contents works. There we go. There's our minus 12345. My data has 6. I just had to make sure that I saved the file before I picked up the debugger again. So then we'll just continue on. Our program will print its stuff out, and voila. So now what do we do? There's one last thing to show you. What do we do when our file might contain something that is not a double? So we're going to get an input mismatch. So, and we know that from experience, but let's just try that again. We're going to use this technique. I'm going to come back in, and I'm going to put a value that's not a double in here, and we're going to see what happens. And that'll tell us what exception we have to handle. So let's run our debugger. And get down to here. Let's go edit our doubles. And I'm just going to change the first line of text and say, not a double. So that cannot be turned into a number. Save the file. Come back here. And we're going to say, while file that has next, that means is there anything in the file to read at all, whether it's a double or not? Then yes. And so now we're going to read a next double. And kablamo, we're going to get this exception here. And the exception was, I got a input mismatch exception. That's the scanner's way of saying, you asked me for a double, but the next thing to read was not a double, and I couldn't turn it into a double. So what's the best way to handle that? And this is where we have a design decision to make about our program. Does our program want to know that everything in the file was a valid double? Or do we want the program just to know whether there was a double or not, or just to know what the double values were, and we throw away the non-double values? So in this example, we're going to throw away anything that isn't a double. So we can try and catch down here. So I'm going to try, we're going to catch input mismatch exception. And then we're going to simply say we need to import that. And then we're simply going to skip it. So there's really nothing that we can do with this exception, but we have to catch it so it doesn't kill our program. So we're just going to catch it, and we're going to have a comment that says, do nothing, because I don't want to have any output coming out of this method because that would confuse the user. So we're just going to do nothing, and we're going to know, and one of the reasons we comment things is we would say, read double values from the file specified, ignore any lines that contain non-double data. So that's actually in the documentation of my method, so that those who read my documentation understand how I wrote the method and how it's supposed to behave. That's why it's important to have documentation. That's why I've been stressing commenting your code, and especially your methods in your classes, so you can explain anything particular about your code. So we've got to do nothing, and now let's run this again one more time in the debugger. We're going to hack our file in between to inject something bad into it. So you know, in your assignment, I'm not going to hack your file and inject anything bad into it. But I do want to see that your code, you practiced good styling in your code. I want you to use this technique to test your own code. All right, so let's go hack, say not a double, save it, come back in, and let's go through here. So we're going to try to read the next double, and we're going to say, nope, couldn't do it. So we go to our catch does nothing, so we're at the end of our catch block, but our program still continues. Except now I've got a real problem, and this is going to go on forever. This is going to go on forever and ever and ever until my battery dies on my laptop. What's the problem here? And this I did plan to show you. The problem here is when you get an exception on the scanner class, when I say, please give me the next double, and the scanner says, I can't give you the next thing because it's not a double, it actually leaves the thing that's not a double in the input queue, so that the next thing that tries to read can maybe try to read it a different way. And so in this case, our do nothing actually should do something. And what we're going to do is we're just going to skip over until the next line. So we're going to say file.nextLine, and that should cover it. That should read all the way to the end of the line. If we happen to have more than one value on the line, we're going to skip everything on that line. And that's okay, because that's not how we wrote the file out anyway. So now let's try this and see if this works the way we wanted it to. And go, and we're going to step, oh wait, I forgot to change the file. So now we've written it out, and we're going to say not a double, and we'll come back, and then we will step. And now we've got that first not a double, and it's not a double. So now we're going to skip past it in the scanner's input queue. And now we're ready to read the next line. And there's our 1.0. And we keep going until we get to the end, and we've got 4 values because the first value in the file was bogus. So we've got these 4 values, and we can see that in our list of data coming back. There's our 4 values minus the 0.0 that we changed to be a bad value. And we return it, and now we'll just go through and print our values out, and we are done. And that's an example of how to write data to and from a file. Read and write, I guess. Write to a file, read from a file. So I'll clean these up, add some comments, and post them to the week 11 discussion, the code samples discussion board. I hope you'll ask questions early and often during the week, and that you'll work on this assignment, get it over with, and then that way you can get an early start on your team's group project. So thank you very much. Good luck.